Okay, let us start. Yeah, Marc is here. Good. Welcome on board. Okay, today we are continuing on with the chapter of budget cost management. That is the fifth topic in the chapter of planning. Okay, like I told you the three kinds of estimate. We have already talked about the schedule. Now we are discussing the cost, and then we have got resources. There are three types of estimate. So this budget or cost is also one of the project objectives. And three project objectives are scope, schedule, and budget. So that way, this chapter is important from both the views, from the view of the estimate and from the view of the objectives also. So this is important. You see, in budget planning, we are going to create a budget for our project, for our life cycle. And naturally, it depends how are we doing our project. If it is a predictive project, naturally, all of the budget or cost planning has to be done in upfront. And once we have established the budget, we will baseline our cost. And then we will get into the execution. If it was a hybrid project, in hybrid approaches, we start with our project management plan, and naturally, we do have an idea of some budget after calculating it from the top down. But we do not break it down to the work package level, and we do not plan for each activity. But we apply in hybrid approaches, we apply agile work at the bottom, and the same approach which is happening in an iteration, we will use that. But in a pure agile method, we will have agile teams collaborate with stakeholders, partners, and finance stakeholders to suggest incremental budgeting approaches. Incremental budgeting approaches is specific to agile. Again, just remind you that in agile, we do not plan everything upfront. We work in iterations. We have a product backlog, just like we did in scheduling. Here for budgeting also, we are going to pick up the highest priority item from the product backlog, and we will estimate only that much work which is to be done in one iteration. Anyways, so these were the three approaches. Coming back to the predictive project planning, just like schedule and other areas of predictive project management, we develop a detailed cost management plan before getting into the execution, and that means we will allocate the cost to each and every work package of the project. Moreover, in scheduling, you have seen that we have broken the work packages down to the activity level. So now I will have to estimate each and every activity. In schedule, we created a network diagram because there were more than one approaches by which we could complete the project. So there could be various paths in parallel. Now that thing which is about the critical path is not relevant to us, because in budgeting, it doesn't matter when you do an activity, if I have the estimate for each activity, I can simply add up all the estimates as if I can get the total budget of the project. That is the cost baseline. So we will talk more about cost baseline and how do we monitor and measure the cost performance throughout the life of the project. So specifically here, I'm going to be focusing on predictive project management. This includes the budget of each activity plus the reserves or contingencies against each activity. It is just similar to what we did in scheduling, that we had scheduled reserves at the activity level, at the work package level, and at the management reserves level. Exactly the same thing will be done here for the budget. Once a cost baseline has been established, we cannot change it because it has been approved by the higher authority, and therefore we call it a cost baseline. And if at all we have to make any amendments to the cost baseline, we will have to seek permission from the authority who baselined it, and they will only allow us to make the changes. Otherwise, we have absolutely no authority whatsoever to amend this cost baseline. As you understand, we had calculated the cost for each activity and we summed it all up, which gave us the total budget of the project. This total budget of the project is called BAC, budget at completion. This is a budget at completion. This is the highest point on the cost baseline. I will show you how our cost baseline looks like. BAC is the sum of all budgets established of all the activities. Or you can say, whatever the work which was planned to be done, each activity, it is sum of all those works. So that is BAC, how it is established. Now, if you look at this diagram, everything will start falling in place. This curved, S-curved line, which is this one, this line is called cost baseline. This is plotted on one side against the time and other side against the cumulative amount of money. Cumulative amount. That means if I am talking about this point in time, we should have spent total this much money so far, right? So at this point in time, we have spent this much money. We should have spent as per the plan. That means at any point in time, at this time, we should have spent this much money. At this point, we should have spent this much money. And at this point, which is the highest point on the S curve, we should have spent this much money. Total money spent at that point in time. That means every point on this S curve is the planned value for that point. Planned value, I mean planned value of money. How much money should have been spent by this time if all the work which had to be done by that point is done. That will cost, that will be our total cost spent at that point in time. Now, all these points on the S curve, whether that is here, 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 or anywhere, that is called PV, which means planned value. So that means I could say this point is PV1, this point may be PV2, this point could be PV3, and so on until the highest point is PV of nth time. PV on the last day of the project. That is as per the plan. So all points on the S curve are called plan value, and the last point on S curve, which I call PVN, is actually named as budget at completion. That is the total budget required to do the whole of the project work. Okay? Are you with me on it?
Yes.
As far as contingency reserves are concerned, they are built into the activities and work packages. Therefore, you can't see them separately. But on top of the budget at completion, management keeps their own reserve, which could be anything which the management have agreed, could be 10%, 5%, 20%, depending on the nature of the project and how much reserve the management wants to keep. That amount is not for the use of the project, but it is kind of a management's own reserve in case your project could not complete in BAC and still some work is left, then the management reserve may be released as a last resort. As I said, other contingencies like the allowance in the work packages or allowance in each activity, that is already catered in the S curve. And naturally, if they have consumed all the reserves of the work packages and the activities, only then we will require to get money from the management reserve. It is not necessary that all of the management reserve will definitely be consumed, but you see, we have got a limit of management reserve, and out of this much total, we may have to utilize this much to complete the project. Okay, so you are fine with the idea of S curve. Each point on the S curve is called a planned value, and that is different from the previous. So it is increasing continuously in a shape of a S curve. Why? The cost is rising slowly in the beginning, then getting to its peak around here, and then again slows down for the rest of the project. That means the portion from here to here is where a lot many activities are getting started. This area from here to here is kind of the initiation and planning is happening where money is being spent slowly. And this is where the execution is being done. The curve has risen because we have to put up a lot of activities which have been started in this area. But once the main quantum of the work is over, the curve again slows down and it curves downwards until it reaches the point PMI-PBA. Okay, so far so good. Did
Yes.
you have any idea of earned value or the S curve earlier than that? Did you know that how it works?
For me, no. It's this is like first for me.
Okay, okay. So we understand that the darker line, which is solid black line, is cost baseline, and this does not represent how the things are happening. This represents the plan. How, according to the plan, the money will be spent over the life of the project. But actual expenditure might be different than the cost baseline, which is shown by this dotted line. It's again a S curve, but this is a dotted line. That is the actual expenditure which will happen on ground. You see, the actual expenditure started at this point, right? Whereas, according to the plan, it should have started at this point. What does that mean? The gap between these two curves starting actually represents the delay in the start of the project. It could not start exactly on the date which was supposed to be the start date of this project. But actually, the expenditure started happening at this point. That means project was delayed by this much time. Project was delayed by this much time. Okay, if I draw a straight line here, that tells us that according to the plan, we should have spent this much money, but actually the money we have spent is only this much. We are spending less, but at the same time, just the expenditure line does not represent how much work we actually have completed. This just shows how much money we actually have spent so far, right? So let me call this expenditure dotted line as actual cost at this point, and maybe if I draw a line here, the actual cost at this point, maybe this is 1, this is 2, this is planned value at this point. So the difference between the planned value and actual cost actually represents nothing but the spending, how much money we have spent and how much money we should have spent by that time. This is not representative of anything. Actually, we need to, in addition to PV and AC, we need to have another line drawn here that could represent how much actual work has been completed so far. That is called a line of earned value, EV. Maybe, I'm not sure, maybe our expenditure line is moving something like this. So this line in red is my line of actually how much I have completed, right? So my earned value is going to be, maybe start from here. This is my earned value. This is my earned value. So you see, there will be 3 lines existing on this diagram, out of which only one line, black one, black S curve, is the line of my planned value. The value of earned value and the actual cost will actually be known when we do it, when the project is started. Then we will say, okay, we were supposed to do this much work, but we actually did this much work. and we spent this much money. So there are three things. Planned value is how much work we should have completed according to the plan by this time, right? For example, if I take this point, we should have done this much work. We should have done this much work, which is according to the plan is budgeted for this value. Actually, what we have earned, I mean, what we have actually performed till now is this much work. I mean, according to the accomplishment of work, the work which has been completed so far is EV. If EV, earned value, is less than the planned value, what does that mean? If EV line or EV point is lower than the planned value on this chart, what does that mean?
So we're spending less, right? At
No,
least
no.
in
Spending line is the dotted line,
oh yeah.
but I'm not comparing it with the spending line, which is actual cost. I am talking about how much work we have accomplished that is earned value. We are not concerned about how much money we have spent, how much work out of the total work, which total work at this point is this land value at this point.
Oh, okay. So meaning
And
we're
the work which we
delivering
actually accomplished is this much. So we have done less than
less.
what we were supposed to have done. Because our earned value is less than our planned value, that means we are behind the schedule. We can't predict the how much money we have spent so far because earned value does not represent the money which is actually spent. That is represented by the third point, which is actual cost at this point. And this distance represents how much money we have spent, right? Now I will tell you how all of this is happening. But before I can get into that discussion, let me uh, explain one thing which is uh, yet not explained on this chart. I have not defined it as yet. So let me remove everything I have written. Can you see the funding requirements, which is kind of in like stairs moving upwards?
Yes.
This line, this is the
Yeah.
funding requirement. Once your budget has been approved, once your budget has been approved, budget at completion, that means you get this X amount of money for the whole project. Then they release the funding to you. But that funding does not get to the project in a lump sum form. They do not give you all the money upfront. Actually, they divide your funding requirements into various installments. Like the first installment is like this much money you will get in the beginning of the project, which should be sufficient for you. This much money. Let me change the color of it. Okay. So this much money is going to be sufficient for this much time. After that, you will get another installment of this much money, which should be sufficient for this much time. Then you get another installment of this much money, which should be sufficient for this much time. And then you get the remaining budget, which should be sufficient for the total work. In case you do not comply with the cost baseline, then you would have consumed all the money at this point, and anything you are spending more would be coming from the management reserve. So this money is coming from management reserve. It is not necessary that all the management reserve will be used, but some of the management reserve can be used to complete the project. Right? Okay. So far, I have introduced you to what is PV, what is EV, and what is AC. Planned value is calculated from the calculations which we did for each activity. The total sum of all the project activities, the total amount is at any point in time is PV, and for the total project would be BAC. So the highest point of PV is called BAC. But by these three items, I can always calculate how far behind I am in schedule or in spending. Spending is something which actual expenditure has happened. If I can compare these two items, they will tell me how far behind or ahead I am in completing the work. That is my progress. I was supposed to do this much work, but I have done this much work. So the difference between these two would be my schedule variance. My schedule, I am behind in schedule by this much time. And if you compare earned value with the actual cost, that will represent your cost variance. So this is an interesting mechanism in which in a single diagram, you can see the performance as far as schedule variance is concerned and the cost variance is concerned. Right? So far, so good? Okay.
Yeah.
So what should be the formula for schedule variance? I said schedule variance is the difference between earned value and planned value, right? Between earned value and planned value. The difference between these two is called the schedule variance. Agreed? So if I ask you, what should be the formula for schedule variance? What would you say? The difference between these two values, PV and EV. What is that?
Planned value minus earned value.
You say planned value minus earned value. Okay. For example, at a specific point in time, the planned value was supposed to be, say, $2,000. That was what we were supposed to have done. But we have actually done, we have actually achieved worth $1,500. That means the answer is $500, but it is in positive. That
Oh, so
means, am I going well?
no.
I'm not
So
going
it's the
well.
other way around.
Yeah,
So
it's
your
supposed to.
formula is wrong, and I have to correct it. It should be
EV minus QV.
PV minus PV.
very nice. EV minus PV, And in that case, this will have to change, and it will be EV was 1500 and PV was 2000. So your answer will be minus 500, and minus indicates I am behind the schedule by $500. The interesting part is I am talking about the schedule performance, but I am talking in terms of money, not in terms of time. That is very interesting phenomena in this, because you see this single diagram, we are going to be using it for calculating the variances of both kind, schedule variance and cost variance. Because we are using the schedule and cost both, we cannot be speaking half in terms of money and half in terms of time, right? It all has to be in one unit. So what we did was we selected that we will be using the money unit, the cost unit. So cost unit is telling me I am short of $500 work which had to be completed, and we are behind schedule by $500. As per the budget, we should have spent $2,000 and completed the whole work. But we only did 1,500 worth of work, and therefore we are behind schedule by $500. So that is how I speak in terms of money to calculate my cost schedule variance. Now, what about the cost variance? What should be the formula for cost variance? Naturally, the two terms involved here is earned value and actual cost. So, what is the formula for that?
So actual cost minus earned value.
Okay, let us say, as you say, actual cost minus earned value. Actually, what you have spent so far on ground, the money you have spent from your account is say $2,500, and your earned value was 1,500. What is the answer? So, does that mean that you have done your job in the amount allocated for that job?
No, it means that you spent more.
So the answer, this is again the wrong formula. I have to again amend it, and I have to I have to change this formula. So that would be
EV minus
EV minus AC, sorry,
AC.
EV minus AC. That would be, what was the earned value? Earned value, as you see, is 1,500, and actually we spent 2,500. That means we have overspent by $1,000. The job we have done is worth $1,500, but we have paid for that $2,500. So we are behind, we have overspent by $1,000, which is not good. So if the answer of cost variance or schedule variance is negative, it is bad. If the answer is positive, that is good. Right? Now, current situation is that we are performing badly, not only in schedule variance, but also in cost variance. That is a very bad indication. Right in the beginning of the project, we understood that we are overspending and we are behind the schedule. So you need to fix this problem. This is maybe the very first month of the project. At the end of first month, we have this reading that we are behind schedule and we are overspending. So I will try to correct the situation by next reporting period. So I will like to do extra work or more work as if I can at least come into positive, or if my earned value becomes equal to my planned value in the next month, probably that would be fine, because I will be, if earned value is equal to planned value, that means my SV is 0. That means I am back on track. I am not deviating. I am now okay. The problem I had in the first cycle, in the first week or first month, I have corrected that by putting in extra effort, and now I am not behind the schedule. So let me calculate it for the next month. So the next month figure is, maybe the planned value was supposed to be 4,500 and I achieved 4,500. That means my answer will be 0. That means, what does that mean? In the previous month, I actually earned 1,500 and now I have earned 4,500. How much more work I have done during this one period, 1 month? I have done $3,000 worth of work, right? And according to the plan, I will be exactly on 4,500 dot. So this minus this is equal to 0. So that means I am on schedule. The problem which I had in the first month, I have corrected that. And now, if I maintain my path correctly and I keep schedule variance to 0 or in positive, my project, as far as the schedule is concerned, is okay. Similarly, the cost variance. We are overspending $1,000. I have to control my costs. So, what is my earned value now? Earned value is now $4,500. That is $4,500 minus my, if my cost variance becomes $4,500, I mean, they both amounts are equal, then my answer will be 0. That means I have not only controlled my schedule, but I have also controlled my cost. But this mechanism of cost variance and schedule variance is a very fundamental way of doing it. You are just subtracting one value from the other, just like the little children do calculations, right? But if you are a little bit more professional, rather than subtracting PV from EV or AC from EV, I would rather like to have a ratio established between them. If I can do this more technical kind of calculation, so I would invent two new terms here. One is called schedule performance indicator and cost performance indicator. And rather than subtracting PV from EV, I would say EV divided by PV. And here I would say EV divided by AC. Now, what if both the values are same? 4,500, 4,500. What is the answer?
1.
If my
1.
SPI is equal to
1.
1, I am on schedule. If my CPI is equal to 1, I am on cost, right? Okay, what is bad? The value is more than 1. Is it good or bad? If the value comes out which is more than 1, is it good or bad?
It's uh, good.
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 Yeah.
And if your value falls behind the value of 1, that is 0.9 or 0.8, that is bad,
Yep.
right? So let's do the same calculation. Here, I say the first month EV was 1500 divided by 2000. So naturally, my answer is 0 point something, which is bad. Say, I don't know, say it is 0.75,
25. Yeah.
right? So it is bad. So what am I doing? My schedule performance index tells me that I am behind schedule. If my value was 1, I was on
On time.
schedule. If my value is more than 1, I am ahead of schedule. Now let's apply the same thing to our CPI. So what do we have? The first month, we had 1500 divided by 2500, right? Again, the answer is like, I don't know, maybe 0.6 or something like that. This is also bad. Got it? I suppose this does make some sense.
Yes.
We can do schedule variance or cost variance calculations. They will tell us whether we are behind or ahead of schedule or cost. But CPI and SPI is a better way of doing it because this is more professional, right? Our answers are going to be around 1, a little less, a little more. But if I'm using SV and CV formulas, then my answers could be very big figures, $20,000 or something like that, or minus $25,000. So that would be cumbersome to interpret. But if the things are in performance index format, then it would be easier to compare and it looks more professional. So just remember, I have given you the formula. I have given you a formula for schedule variance, formula for cost variance, formula for schedule performance index, and formula for cost performance index. Got that? This is all the calculation I need. And a little bit more. There are a couple of 1, 2 more formulas which are not really very difficult. This is all about earned value management. This is the performance measurement mechanism, not only for cost, but also for schedule performance. So this is very interesting that using the same method, the earned value method, we are able to check the schedule as well as cost performance. That is why this method is very popular and is being used in project management for quite some time. But unfortunately, all the organizations are not using this method to calculate their variances, right? So, generally, people do not have an idea that there can be a relation between schedule performance and the cost performance. They are trying to estimate the schedule performance with a different mechanism and cost performance with a different mechanism. And they don't have any relationship between the schedule performance and cost performance. But by making this formula, we have established a common ground between the two. Earned value is the common ground between two formulas. This is the only thing common in both of them. Now, let me remove all these drawings and tell me, what do you think? How do you measure the progress of your projects? Naturally, you are not using earned value method. You don't draw this kind of a graph or something like that. How do you do that? If someone asks you, what is your current progress in time? What would you say? In your
So
project, how do you measure
yeah.
the scheduled performance?
So for me in my projects for schedule, I would tell them what phase we are.
What?
So I work on what phase, project phase. So I work on predictive mostly.
Okay, good.
So I tell them what phase we are and how many percentage we are,
Okay,
and if we're on track, right, to finish within the scheduled phase.
okay. For example, let me draw something. For example, this is your project. These are your activities, maybe
Yeah.
like this, something like this, something like this. This is your schedule. This activity was supposed to be 10 days long, right? It should be done in 10 days, but it actually gets completed in 12 days. It is delayed by 2 days. How do you calculate? How do you predict how much longer this activity is going to take? Or how much earlier this activity can be done? In, in your current calculation, there is no way that you compare the cost with the schedule. Schedule calculations are separate. And actually, what you are not telling me is you say, okay, by this date, we are 80% complete. So we need to spend 2 more days to do the complete work. So I am trying to measure the progress of the schedule according to a percentage level, right? Isn't it what you do?
Yes.
When we do it like that, I have a very strong argument that do you think percentage is a valid method, is an accurate method? How do you know that your project is 80% complete? Have you measured it in some manner? Or it is just an approximation?
Well, I think approximation, unless
It is
we are in the
approximation.
user
Yes,
testing.
you are very right. But unfortunately, whenever it comes to doing any percentage calculation, we are very confident about our percentage calculation because it looks quite accurate, like 80.99%. We think, oh, this is very accurate, but this is not accurate. Percentage calculations is an approximation you are making, which is not at all accurate. We have to resort to some other method to accurately calculate how much we have done and how much is left. What is this 100%? 100% is just like I do qualitative analysis. I say, okay, uh, I have a scale of 1 to 5. Please tell me approximately how much work has been done. You say, according to me, it is 4 units work has been done out of the 5. So you are just making an approximation. Now, if I can convert this scale of 1 to 5 to 1 to 100, does it make any more accurate? It is one and the same thing. Whether I count it from 1 to 5 or 1 to 100 or 1 to million. whatever I'm doing, although the graduations between them are getting smaller and smaller, but I am still making a guess. Although the figure looks very promising, 66.78% looks very promising, it looks very attractive, but that is still an approximation. But if I use the method I just told you, that is an absolute calculation that has no frills in it. That is exactly where we stand. When we start, when we have to calculate schedule and cost both on a same diagram, so we have an option. Either we can do the cost variance or do the cost calculations also in terms of percentage, which again, many people are doing it. They try to do the cost calculations and the schedule calculations in terms of percentage, which I have proven to you that percentage is not an accurate way of calculating anything. Percentage is just giving you an impression that you are being accurate. Actually, you are making a lot of approximation there. So percentage is not a good way to measure the schedule or the cost. What other option do I have? The other option is if I can measure things in amounts of money, right? Amount of money is a established fact that money is a detailed calculation. If I tell you you have spent $10,250.20, that is an accurate figure. So rather than calculating everything in percentages, if I can calculate it in terms of money, not only the cost variances and cost calculations can be done very accurately, but our schedule calculations can also be done very accurately. So let us forget about using the percentage method. Percentage method is a flawed method, is a approximate method. This is good for nothing. Are you with me? That's how I make my case that earned value management or earned value method is the most accurate mechanism you could have, not only to measure your schedule, but also to measure your cost. And you could do that all in one formula, all in one diagram, and you could track your progress very correctly. Does it make any sense so far?
Yeah, we're just thinking on how we can relate it to our current projects.
Okay,
Yeah.
I'll show you. I'll show you. Okay, this S curve is actually, say, okay, let me tell you. For example, till this point, let's say this is actually the schedule you had to do. On top of the schedule, at this point, we, according to our cost baseline, we should have spent this much money, right? So that means, what are we doing during this time? We have just done activity number one. This is our activity number one. That means if the amount shown here says total budget is $10,000 and this much is, say, $1,000, that means my estimate for activity one is $1,000. Okay, if I draw a line here, I would say by this time I should have spent this much money, and by this time what all has been completed, should have been completed: activity A, activity B, and activity B and activity C. That means this amount which comes out to be around $7,000, actually is the estimate for this activity, and this activity. Because this activity has yet not been completed, so we will ignore it. So that means 7,000 is the budget for activity A, B, and C. Right? So by this point, this is the 7,000 point, we should have spent $7,000, and we have, if we have completed these activities, we have achieved that budget. Can you see the correlation between the schedule and the cost baseline?
Yeah. So actually, this activity bar, the bars helped me understand as well, because I was confused, or maybe I could not digest right
Exactly.
how does activities relate to the cost and time if I'm not the one doing the work. But if
Wonderful.
I have like a checklist with a schedule and see, okay, activity A, B, C is done, then yes, this is actually,
So actually, this is
making
how
sense.
we translate. Actually, if you can draw your schedule on top and you can draw your cost baseline on bottom, you can relate with them which activities should have been done, and you already know when you have estimated the budget for each activity, you knew what is the budget for activity 1, what is the budget for activity 2, activity 3, right? So there are, say, 1, 2, 3, 4, 5, 6 activities in your project. So if I can add all of that, I will actually get this value, which is $10,000. And maybe there is some extra money which is in the management reserve. But your project budget is actually $10,000, which I written here. This is $10,000 for these 6 activities. And the first activity may be worth $1,000. The this activity may be $5,000, and this activity might be $1,000. That is the 7,000 figure. And the remaining 3 activities are, say, $1,000, $1,000, and $1,000. That totals up to 10,000 total. Right? Just tell me if it makes some sense. If you are
No, it makes
convinced,
sense.
then
Yeah.
now you can be interested in learning it further. I'm not going to go in a lot of detail about this, because this calculation we can go on and on forever. We can do many examples to prove that, but I don't have time for doing that. But I just wanted to portray to you the importance of this method and how good this method is. So for the time being, I'll erase all these times. And this is your basic diagram for earned value management, right? I'll get back to the calculations again. Okay. As far as cost is concerned, what is my historical data? Like, if a similar activity we have done in a previous project, right? So when we are trying to estimate the cost of a current activity, I can create an analogy with a previous experience and try to estimate uh, the amount for that activity to be how much from the historical data. But the estimation methods, as we studied in schedule, they remain the same for cost also. What were those estimation methods? Analogous, parametric, 3-point, and the last one was bottom up. Exactly these 4 methods will be used for estimating the cost also, like we estimated the schedule. And even for calculating the resources, again, we can use the same 4 methods. And I told you when I was describing all these 4 methods, I told you The most accurate and the most detailed method is bottom-up estimation, which is the detailed calculation for each activity, right? For each activity, we calculate how much money is required to do this job and what equipment cost is, what salaries are, and we add that up to calculate the cost of that activity. That is the most detailed calculation. The second best option could have been a 3-point estimate. And then we could have the parametric estimate, which is not really very accurate, but it is good. It is better than the analogous estimate. An analogous estimate is a pure guesswork. There is no accuracy in analogous estimate, right? So now you understand, when the project manager and his team are calculating each and every activity, they are doing what method? Bottom-up estimation, right? But the other people who have created an opinion about how much money will be required for the project, they might have resorted to other methods, like analogous, like parametering, like top-down. So, but those are not as accurate as the bottom-up method. Bottom-up method is the most accurate one. So you understand, the estimation techniques remain the same, whether it is schedule, it is budget, or it is resources. But the interesting thing you have learned here is that rather than keep taking the progress of time separately and progress of cost separately, it doesn't make much sense, because it may appear that we are doing work very fast, but on the other hand, we might have been spending millions of dollars, whereas we were supposed to just spend $7,000. You end up doing the whole 7 activities of the whole project, 6 activities. Maybe in 2 days you complete everything, but at 100 times more cost. How does it look attractive to you? There must have been some relationship between the schedule and the cost, as if we can say that, we have not gone wrong drastically. Somehow we have to keep our schedule and cost aligned, and the only possible method for that is using the earned value management method. You got that?
Yep.
As far as resources are concerned, naturally we add the cost for each resource. But you remember, when we were talking about schedule, we said that we estimate on the average resources and later we adjust the schedule according to the exact resources. So, resource computation is resource computation, the cost computation, and the schedule computation must all be done in unison if I want to employ the right number of people at the right time. How much money is required, we can only calculate when we know exact resources, right? So that there has to be a coordination between all the 3 calculations: schedule, cost, and resources. Only then we will have accurate figures. Anyways, as far as the costing is concerned, that is much simpler than schedule. In schedule, we had to create a critical path and all that, which is not the case with the cost. In cost, we simply can add up the cost of all the activities and we will come up with the total BAC. Right? What about the agile project? Now, it is quite mind-bending to understand that agile is not like the predictive. Predictive project may look like very accurate because we are calculating things down to the decimal point. But in Agile, we say it is a wastage of time, calculating everything to that level of accuracy, wasting a lot of time. It will be all right for me in Agile if I am making a fairly good guess and I am catching up to that, if I can maintain that figure. So we do not estimate cost or time in case of a agile project. You remember I mentioned we look at the complexity of each user story and allocate its R value, which is not time, which is not cost, which is not resources. But we use a blended rate, and that effort is represented by a kind of a arbitrary figure. It is not time, it is not cost, it is not resources, but it is just the level of complexity in that activity. So I have 200 user stories. Some stories are more difficult to achieve. And why they are difficult to achieve? Maybe they are taking more time. Maybe they are taking up more money. Maybe there is something else. But I would just grade them as a higher estimate point value. This estimate point value I have mentioned earlier is called the story points. Every user story will be allocated certain number of story points, which will represent how difficult this activity is to be done from the point of view of time, cost, or whatever. But I am only concerned about how difficult is it. If it is more complex and more difficult, it would have more story points. Just like if an activity is taking more time, it will have longer length than other activities. So we are not talking in the terms of length or money. We are cost or money. Time or money. We are talking only from the point of view of complexity, how much effort is required. And effort is arbitrary. It is not time, it is not cost, but a blended effort. So one user story may have a story point value of 200 story points. Another story could have just 5 story points. The story which is having just 5 story points, that means that is simpler, easier, and not complex. It is not taking a lot of time, it is not taking a lot of money. But the story which has the story points of 200, that is more complex, that may take more time. I don't need to know how much time it will take. I understand that in Agile, the user story is definitely much smaller than the size of the iteration. Therefore, I know this user story can be done during this iteration. So all the user stories I have picked up to do in my first iteration, I understand that this can be done in 2 weeks. Right? Whether it is going to take more time or more complexity or less time and less complexity does not matter. I have committed, the team has committed that we will complete these 20 user stories during our first iteration. That means the length of time each user story is going to take might be different, but they can be done in 2 weeks. All of them. Okay, if you have understood my point, and we do understand the concept of story points being allocated to each user story, those story points are a scale to measure. When we are picking up the work for our iteration, we first have to decide what is our capability, collective capability of the team. Team has got 10 people. Naturally, when we join hands together for the first time, we do not have much of idea because we have not worked together how much work can we do together in 2 weeks. 10 people working for 2 weeks. How much work they can accomplish? So again, they will talk in terms of story points. We will ask all the 10 members, what is your capacity to work in 2 weeks? He says, I can do 100 story points. Another person says, I can do 200 story points. So according to their level of expertise, they will give their story point, and we would then add that all up, and we will say, okay, that means we can accomplish 500 story points in 2 weeks. So now when we are picking up the work, first of all, user stories should be small enough. No story would be 10,000 story points. The story points would be something ranging between 1 to 300 or 400, right? So I will go to the product backlog. The team will go to the product backlog. They say, we think we can accomplish, say, 700 story points in one iteration. So what is the story point for the top ranking, top listed item on the backlog? So say it comes out to be 200 story points. We say, okay, out of the 700, we can do it. Pick up this work and we take it along. Then we say, what next? Next one is 100. I say, okay, pick that work also. Now we are left with 400 story points. Then we say, what next? Then it is a story, it is only 10 story points. We keep picking them until we reach approximately closer to the 700 story point, which we assumed that this is the capacity the team has to accomplish during one iteration. Got it? So I have picked, say, around 8 different user stories from there, which are approximately 700 story points. Got it? Once we have done that, now I have a very fair idea. I can calculate the cost from this calculation. Let us see. It is very funny. I am not calculating the cost of any activity, but I am trying to calculate the cost of the whole project based on this story point formula. So how do I do that? So there is a very simple formula for that. It says there are 10 people on the team. What are their salaries for 2 weeks? Add that all up, right? Their salary for 2 weeks, because these are people who are working on the project. So for example, their salaries are $10,000. Okay, how many story points can they accomplish in one iteration? I say 700 story points. I will divide 10,000 by 700. What will I get? I will get cost per point. Per story point, my cost is, what is it? 10,000 divided by 700. That is, what is 100 by 7? It is around $120. Is it right? Around $120 is the cost of one story point. So what should be the cost of the whole thing? Of one iteration? 700 multiplied by
700.
120. That is my budget for this iteration, right? And what about the whole project? If I can apply this formula to the whole product backlog, I can come up with an approximate figure of amount required to complete the whole project, whole agile project. So without going into the difficult calculations of each and every activity and each and every activity's time, we have invented a new formula, right? Cost per point. But in addition to that, if we can improve that formula, because naturally, during every iteration, apart from the human resource, there are other expenses also, like equipment and tools and things like that. So what I do is, whatever is my cost per unit, I multiply that with total point value of items to be completed. Say we have to complete 700, multiply it by 700, and then add other expenses to it. This will give you your forecasted budget for the iteration, for the release, or even for the whole project. This is fantastic. This method is completely unconventional. This doesn't do things like in a predictive project, but still it achieves those efficiencies which a predictive project cannot. Moreover, we are flexible in Agile. We are highly flexible, requirements can change. In predictive, we are very strict about not letting anything change. Anyways, now you understand how do we calculate the cost in an Agile project. Do you have a fair idea now?
Yeah.
Just keep that in mind, because that is going to help you a lot. Okay, if it was a predictive project, then we are doing a lot of calculations, a lot of calculations. For every activity, we are saying, okay, what is the direct labor? What is the material cost? What is the equipment cost? What is the facilities cost? You know, we are wasting so much time in these calculations, whereas Agile has done it like a jiffy. And by the way, the Agile calculations are much more accurate than these calculations. Moreover, Agile also allows for change in requirements, anytime, anywhere. Whereas if we ask the predictive project that we want to change something, they will say we have to go back to the drawing board, we have to recalculate everything, and then we'll come up with a figure. And then we will tell you this is total waste of time. Right. We do understand that in a predictive project, we do it very deliberately. We spend a lot of time in calculation, and still we don't have any flexibility. So the various kinds of estimates in a predictive project, which are created at different moments in the life of that project, is kind of some of them are listed here, but let me separately list them down, because I have got more types than written here. The most approximate method is called lump sum estimate. Now, this is that kind of estimate which could happen when you are having no idea what the project is. Just the idea of this project has come to the mind of the CEO of the organization, and he calls one of his consultants or one of his friends who had experience in this kind of job, and ask them, what do you think? How much budget should we have for this project? Without any calculations, just purely on guesswork, he says around $2 million. This kind of estimate is not accurate at all. The question is, how much is it accurate? So I would tell you that this kind of estimate is accurate to the level of minus 50% to 150%. Sorry, minus 50% to 200%. That means if the estimate was given to you was $100,000, that means because lump sum estimate is not accurate, it could be done earlier or it could be done later. It could be done in less money, it could be done in more money. What less money is? Less money is that it could be done in $500,000 or it could be done in $2 million. So the variation in the lump sum estimate is too big because it is not accurate. This is done before the business case is developed. It is the arbitrary approximate calculation which the CEO of the organization is making on his own. When we are doing, when the business analyst is creating a business case for that, he also does a little bit of a calculation, but that is also not very accurate. But this is better than the lump sum estimate. That is called the rough order of magnitude. So rough order of magnitude has an accuracy of minus 25% to plus 75%. Got it? Then we have another kind of estimate, which is called budgetary estimate, and its accuracy is going to be minus 10% to 25%. And then is the definitive estimate, which is bottom-up estimate. This is most accurate in terms of the predictive project, and its accuracy is minus 5% to 10%. This estimate applies to business need, and it is done by the one who proposes it. This estimate is done by the business analyst for what? For the business case. This estimate is done by the accounting people to allocate the budget for the project. They don't want to go into very much detail. So this is during the project, but by the finance department or something like that, they are allocating budgetary allocations according to that, and this is by the finance. And this is by the project team, and this is the most accurate method in predictive, right? So I hope you understand this calculation. Do you have any questions about these methods?
None for me.
Okay, if you are comfortable with that, I suppose we can move ahead. Let me clear it out and let us move on to the next slide. Now, this is how the project budget is going to look like. Every activity, we will, I'm talking from the predictive point of view. Every activity will have a cost estimate. Agreed?
Yes.
But there is an element of risk in every activity. Some activities carry little risk, some activity high risk. So based on the element of risk in each activity, we may keep a activity contingency reserve alongside every activity. Right? We add up all the activities along with their contingency reserves. And I'm not talking about the whole budget. I'm just talking about our work package. Like construction of our wall in the whole building of our wall is my work package, and there are many activities involved in that work package. So all the estimates of those activities plus their contingencies will add up to the work package cost estimate. Are you okay with it? There
Yes.
could be many work packages. Maybe there are 40 different work packages in the project. Each work package will be divided into certain activities. Those activities, estimate is created along with their reserves, and adding that up, we will find the total estimate of one work package. And because work package is also a work, there could be a risk at the work package level also. The work package also reserves a little bit of contingency reserve with them. So all the work packages and their contingencies within a control account are added up, and that is the control account total. Now, what is a control account? This is a accounting package. We have to construct this building, and this building has been divided into 5 parts, and every part is considered a separate control account. In the terms of finance, there is no reserve. When we are doing banking calculations or financial calculations, the total should be accurate. You can't say that, what if there were $10,000 in the account, and after your calculations, you could not, come up to the same total. Your total is $10,001. So is it correct? When you check the accounting books, you find that the accountant has calculated $10,001 expenditure today, whereas we had only $10,000 at the start of the day. Is there something wrong? What do you say? From where this one extra dollar has come in? That is not allowed in accounting. If there were $10,000 to start with, the total calculations will reveal that these $10,000 have been spent. Or, how can you say that we have spent $10,001 out of 10,000? Are you with me on that?
Yes.
So, in accounting calculations, it is not allowed to have any kind of contingency. But as far as the activities are concerned, they have risk, they have contingency. The work packages are concerned, they have risk, they have contingency. But the sum of the work packages within a control account would be just the control accounts budget. There were 5 control accounts. So when you add up those 5 control accounts, that will give you the cost baseline, which is your S curve. And on top of the S curve, the BAC value, budget at completion, on top of that, we have some management reserve. If the management reserve is added to the cost baseline, that is a BAC value, then it comes out to be the total budget for the project, which includes the management reserve. Are you okay with this idea?
Makes sense, yeah.
Does it make sense?
Yeah.
Yes.
Okay. So this is how your total budget components are looking like. Let me start. Project budget has been divided into 2 parts, the management reserve and the cost baseline, which is BAC. This cost baseline is made up of certain control accounts, say 5 control accounts. So whatever was the total of all the 5 control accounts, that becomes my cost baseline. I add a management reserve to that to come up with my project budget. Now let's work backwards from the control account. Each control account might have certain work packages, and those work packages might have certain contingencies associated with them. So the sum of all the work packages within that control account plus their contingencies will add up to the control account. And for each work package, there might be 5 or 6 activities in that work package. So sum of all those activities plus their reserves will add up to that work package. And then forward to the control account, then forward to the cost baseline, ultimately the total project budget. I hope you understand how this project budget is depicted on this diagram. Are you okay with it?
Yep.
Okay, good. Before we can proceed ahead, I think we have been speaking for 1.5 hours now. We deserve a break. So let us have a break of for 20 minutes now. Will that be fine with you?
Yes.
Sure. Yeah.
Okay, so we are breaking off for 20 minutes and here you go.
Hi, Suhail.
Hello, welcome back. How was the break?
Good, refreshing.
Mark is not here.
Let me ping him. He might be there already.
Mark, are you there?
Mark is not responding to me as well.
Mm. Okay, I think we should start because we don't want to
Okay.
waste our time. Okay, so in an adaptive or hybrid budget, naturally, this is not as explicit as the predictive budget is. So what we do is in agile, we focus on short-term budgeting. Although we can project that budget onto the whole project or onto the whole release, but at a time, we are just concentrating on one iteration at a time. So we focus on short-term budgeting and metrics versus the long term. Whereas a predictive project is calculating everything upfront and they take a lot of time in that. And even then, things do go wrong in predictive projects. Agile project, we are highly flexible and we are working on a very lightweight model. We work very quickly, we do our calculations very quickly, and we don't plan everything up front. Set time periods for work and prioritize work within those time periods. Those time periods are our iterations. Base cost on the resources used for that time period, like as we calculated, cost per unit, right? So a hybrid is also like, partially predictive and partially agile, but this has certain elements of agile and iterations are calculated exactly in the same manner as in agile. Budget considerations. Estimate budget based on the length of the time of the project, right? I'm talking about the agile. So we estimate budget based on the length of time of the project. Burn rate. What is a burn rate? Burn rate is like, a candle is burning down. Initially, it is a full candle, but as it burns down, it keeps getting shorter and shorter. Similarly, if I know the total budget of my agile project and I say, okay, out of the total budget, this much has been spent, and now this much has been spent. So the remaining budget keeps getting lower and lower. So we follow the same burn rate analogy, and we have number of team members available, 10 members are there, and then we kind of calculate a blended or actual team member rate and time of involvement and assumptions of full-time team involvement. If additional equipment or supplies are required, then we estimate those things in addition to that. I am just trying to explain the way we just calculated the story point calculation, right? This is exactly the same thing it is saying that once you have got per unit cost, this is comfortable for you to calculate the whole budget for the whole project or for the whole release. That is exactly the point that with little effort, we achieve bigger things. Question: what is included in activity cost estimate? One statement is true. Please pick the right answer.
For me, it's going to be letter D.
D. But
Continuous
D
inclusion.
includes indirect costs, right? Indirect cost is an expenditure which is not attributable to the activity. It could be like, on the overall cost, you add certain indirect costs, like expenses on other things. So it is not D, but it is B.
Okay.
Indirect cost is a unnecessary addition here.
Okay.
What is the process to create a project budget?
Letter C. If it, yeah, predictive C.
Actually, it is B. It is talking about creating the project budget. Combine, you remember that diagram in which we calculated upwards work package to, activities, work package, and then cost accounts and BSC and then total budget. That is talking about that. Combine all individual activity cost estimates and contingencies, aggregate them to the entire project, submit this to the sponsor, modify if
Okay.
necessary. That is the correct answer.
All right.
Our project manager is using a time-phased budget to measure the cost performance. What is that budget called? Time-phased budget. What is that called? Yes, Mark?
I'm guessing A.
A, yeah. Cost baseline is the only estimate which is time-based. Oh, sorry. Cost estimate? No, it is wrong. A is the correct answer. A is the correct answer. I'm sorry for that. Okay, we are done with the budget, and now we are moving on to the risk, right? So ready for that? Okay,
Yep.
as far as risk management is concerned, naturally, there are many terminologies to understand here. First of all, what is risk? Risk is a probability. Risk is an uncertainty. This is likelihood of something good or bad happening, right? We are not sure if this will occur, but there is a likelihood it may occur. Now, risk is not something bad always. Risk could be good and risk could be bad. Actually, I know in the English dictionary, when they define risk, they define risk in a very bad language. They think that this is something disastrous, this is something bad. But by definition, risk is not good or bad. Risk is just a uncertainty. There is a likelihood of something happening. Something good or bad can happen. So risk is not good or bad. Risk is an uncertainty. So risk originates from a wide range of known and unknown causes within and outside the business environment. Meaning that because it is an uncertainty, we try to hunt it down. It may be, from previous experiences, we might have observed that these kinds of risks may occur. So we may seek guidance from there, or this may be coming from unknown causes which we can't even understand. Therefore, I would say risk could be categorized like those which are known. Like we know that this thing can occur and we know how much damage it can cause. This is the known risk. Then there are known unknowns. Known unknowns are those which are, we know that something like this can occur, but we don't know the amount of damage it can cause. Then there are unknown unknowns. Unknown unknowns are which cannot be conceived by us. We can't think of this thing happening ever. So basically, what we can do is we can identify those risks which we can conceive. they could be known, or they could be known unknown, and then we start dealing with them. Then there is another thing which is called a trigger condition. What is a trigger condition? A trigger condition is an event or situation that indicates that a risk is about to occur. We have identified a risk. It may be occurring after it. There is likelihood is that it will occur after 1 month. But if we take any action about that risk right now, we may be wasting money because it is too far away and it may not even occur. So what we do is we plan for it, but we wait for a trigger condition to occur as if we can start taking action. Remember, all the actions against the risks we are attempting, they must be taken in a timely manner, but it doesn't mean that they can be taken after a risk has occurred. The action on risk should be occurring before the risk has actually happened, as if we can somehow reduce the impact of the risk on the project. I hope you understand that point. So these trigger conditions will let us know that this risk is near. For example, there is a risk that it might rain and it could disturb our construction work. And the most sensitive construction work is, for example, it is happening on 23rd of March. So there is a likelihood if it rains on that day, our construction work will be affected by it. It is only for one day, 23rd of March. That's all. Okay. So what we can do? We have identified this risk in the month of February. So we don't need to take any action except for we should plan for it. Then should we take action when it is already very close for the risk to occur. For example, what could be a trigger condition for rain? How would we know that it is now about to rain?
The sky, yeah.
Yeah.
Yeah, it is cloudy, it is windy, or something like that. That could be a clear indication that if on the morning of 23rd March, we see that there are clouds on the sky and things, we should start taking precautions, right? Whatever the response we have created, that will be triggered. But remember, a risk is a risk when it has yet not occurred. Read this last statement. If a risk becomes an issue, you must act, right? And risk becomes an issue when a risk has occurred. If this risk occurs on 23rd of March, then the damage has been done. Now it becomes an issue and we have to deal with the issue. Issue management is a separate subject. Risk management is a separate subject. But a risk may become an issue if it occurs. If it doesn't occur, then it cannot become an issue. All the action on risk should be taken before it has become an issue, because all actions after the risk has occurred will be treated under the heading of issue management. That is no more risk management. Risk management is done and dusted. Therefore, all the action on risk must be taken while the risk is still alive. Risk could be negative or risk could be positive, which I have mentioned already. So the positive risk is called an opportunity and negative risk could be called a threat. These are some of the risks identified by the project manager Ang Fen, who is the project manager for the Suhail Lifestyle Center, your case study. So these are some of the risks. Read through them and tell me, what do you find so special about these risks? Are they really the risks?
Mm, I think,
So they are risks.
yeah,
I would say, yes, of course, you are right. They are risks, but they are very poorly worded risks. They don't really indicate what is likely to happen, what is so bad about it. Like, for example, it says building code compliance. Well, building code compliance is something we do. What is the risk in that? Actually, risk is he is unable to define here. Actually, risk is that we may not be able to comply with the building code, and there must be reason behind it. But building code compliance is not a risk by itself. Anyways, I agree that these are all various kinds of risks, but they are very poorly worded risks. They are not rightly written down. How our risk should be written? Our risk should be written in a complete sentence composing of three parts. The first part should be the cause of the risk. Second part should be the risk itself. Third part should be the effect of that risk. So, for example, you say, because of the inclement weather, it is highly likely that it might rain and affect our construction work on 23rd of March. So this is the complete statement of the risk. We exactly know what is the precondition, what is the cause, because there is an inclement weather, because there are weather reports that the weather might be bad that day. And the risk is that if it rains, right? What is the effect of it? Effect is we won't be able to continue our construction work that day. And the ultimate result is that we will be delayed by it. So, howsoever, you have to build a complete and consolidated, comprehensive statement of the risk. Otherwise, it may be a wrong statement. It may be an absurd kind of a statement. Like when I ask my subordinates, okay, identify a risk. What could be the risk? They say time could be a risk. No, that is completely absurd. How can time be a risk? Time is a fact. Time is available. How can time be the risk? They need to explain it. Moreover, as such, time is not a risk at all, but it's an impact on the time. There are various risks which can impact that time, right? So we should identify it in complete sense. Anyways, we acknowledge that these are the project risks. Maybe they are not rightly worded, but they are project risks. And now let's proceed ahead. What is the business context? Actually, this risk concept of risk came out of business. When you invest your money in a business, you are taking a chance. You may succeed or you might fail. So there is an opportunity and there is a downside to it. Either this can happen or that can happen. Either you get the profit or you get a loss in your business. But from the risk management point of view, this is not that simple. In risk management, it systematically maximizes the probability and positive of probability. Probability of positive events, I mean the good risks, the opportunities. For opportunities, we want them coming. We welcome them. Therefore, if there is a positive risk in our way, if there is an opportunity in our way, we would like to embrace it. We would like to increase the probability or likelihood of that thing happening or the benefit which is likely to come, we want to enhance that. But if there is a negative risk, our strategy will be reversed. We would like to minimize the probability and consequence of a negative risk. That is how we deal with risk management in projects. Well, in a predictive project, we have a comprehensive risk management planning going on, and we try to identify as many risks as possible. But practically speaking, this is not possible that you can identify all the risks. There will be certain risks which will remain hidden all the time. They will only be made visible when they have become an issue. So those risks we can't deal with. But we can deal with those risks which could be identified, which could be either known, or known, unknown. We can identify them and we can start planning about them. But in agile and hybrid, we do not have this kind of concept. We don't have to do upfront risk management for the whole project. But we are, like in agile, we are only worried about the ongoing iteration. We do the planning only for that iteration. We do the risk management only for that iteration. And all kinds of effort estimations are done for that iteration. Right? So we progressively elaborate. We do one iteration at a time. When we are done, then we move on to the next iteration. And that way we keep planning and keep doing. So this approach is very different from the predictive project management. Okay, before we can develop a risk management plan, we must have a risk strategy, which is given to us by our organization. Just like the quality, we said we have a quality policy coming from the organization, which we must follow. Similarly, there is a risk strategy, there is a procurement policy. All of these things are to be considered when we are creating the relevant management plan. So in this case, it is a risk management plan we are talking about. What is the governance and guidance provided to you as a risk manager, that what is the risk strategy from the organizational point of view. Here, I need to talk about certain concepts like what is a risk appetite? Before you can answer me, forget about the risk. Tell me, what do you mean by appetite? What is appetite and what is your appetite?
It's like if you're hungry or
Exactly.
yeah.
That is the answer I was expecting. Yes, when I am hungry, I want to eat. And I can eat only a limited amount of food. I can't eat everything up. I can't eat the whole kitchen of a hotel. I just can eat how much my stomach can absorb, right? If I keep eating and eating, I will start vomiting. I'll get out of control. So, your appetite is the acceptable range of risk you can take. You can eat only as much as you can digest. You can't eat more than that. So that means anything which is within your appetite, that is bearable for you. You can take that much risk without any problem. But if you keep eating, that you won't be able to eat anymore at a stage, and that will make you sick. So anything which makes you sick is beyond your appetite. I hope you understand. Right.
Yep.
So just keep that concept at the back of your mind, and let us talk about various risk attitudes. The risk attitudes could be like, whether you are a risk seeking person, a risk neutral person, or a risk averse person. What do you think is the best approach? Should you be a seeker of the risk, or you should be neutral about the risk, or you should be averse to the risk?
For me, seeking.
Out of
Kasi
these three, seeking looks like a good opportunity, but these are just the attitudes. Now, let us say what is good about seeking. Seeking means you are welcoming the risk. You are welcoming the notion that risks could occur, and you are looking after them. You're looking forward to identifying the risk as if you can deal with them. But at the same time, a person who is stupid enough and just trying to prove that he is very brave, he is taking unprecedented risks for which he is not even prepared for. That I would call a pure stupidity. Just because you are very brave, you can't go and bang into a wall, right? That kind of risk-seeking attitude is completely negative. But yes, I agree with you. Out of these things, risk-seeking is the only most appropriate strategy if done in a calculated manner. A good risk manager takes the calculated risk. He doesn't take goes and bangs into the risk where he knows that it will be dangerous for me. Why should I do that? It should be a completely senseless person who does that. Then there are people who don't care about risk. They are neutral about risk. They know that this risk could be there, but they are not ready to take any action. They say it is all right. We will see it. It will happen. These things keep happening. So this is a risk neutral person. This is not also a good attitude. But risk averse is the worst of all. That is a person who is so much afraid of the just mention of a risk that he starts trembling when I mention a risk. He doesn't want to acknowledge that risk can occur. So he is keeping himself blindfolded all the time as far as the risks are concerned. So you have to understand what kind of attitudes do exist in your organization, what is the risk appetite in your organization, how much risk is too much for you, and what kind of attitudes do we carry. After you understand this, let us talk about risk threshold. Risk threshold is the limit of the risk within which threshold you could absorb it. Well, like you can eat as much as you can digest. That is your appetite. But you can be forced to eat more, which is beyond your appetite, but still you can survive it. But there is a limit to it. There is a threshold to it. If you cross that threshold, then you can't control the risk at all. So I would say risk appetite is you are able to take on that risk with ease. And risk threshold is the limit we are kind of stressed out. We are having difficulty in absorbing that risk, but we absorb it until we reach the threshold. Threshold and the limit within which we can take on the risk. If this risk is bigger than us, if this risk is beyond the threshold defined for our tolerance, then I would say that such a thing could be identified as a risk. Anything which is absorbable, which is within the appetite, which is within the threshold, is not considered a risk for that organization. Now, it is not the matter of how you think about risk. It is how you, your organization, and all of your stakeholders jointly think about the risk. So you have to determine the risk appetite and the risk threshold for the whole project. All the stakeholders, we must summarize their opinions, and ultimately then we will define what is the risk threshold in our organization. how much is okay to be accepted, how much we should take any action on, and things like that. Next, when we start identifying the risk, we create a risk register and keep noting down all the small and big risks in that. That is our risk register. And as I said, that risk, anything entering a risk register is which is beyond our risk appetite or which is outside of the risk threshold. Now we'll talk about it, but there are management guidelines how to use qualitative and quantitative risk analysis tools. Then we set a maximum risk exposure level that can be managed without escalation, meaning that, well, we are dealing with a risk, but if the risk exceed a certain value, then it is out of our control. Maybe we have identified that risk, but when we analyze it, we find it that this is beyond our responsibility. So we will identify the right authority to deal with it and escalate the matter to them. Right? Therefore, I can say that for risks, we have got limits defined for the project manager, for the team member, for the sponsor, for other people. So if risk is bigger than your project, then probably you have to forward it to the next higher level. Escalate it to them as if they can deal with it. Define and refine the risk management approach. You develop a risk management plan in the beginning, and risk management plan will actually include things like this. What is the risk strategy, as we mentioned earlier? What is the methodology of dealing with the risk in your organization? What are the various risk-related roles and responsibilities? From where the funding for these risks is coming? What are the timing these risks could occur? What are various risk categories in which you would like to divide these risks? How do you categorize the risk? And stakeholder risk appetite. It is not only the stakeholder, this is the collective risk appetite. And anything which is within the appetite will not be considered as a risk. Anything which is beyond the appetite would be considered as a risk and will enter into risk register. What is the definition of risk probability and impact from your point of view? How probability and impact can help us design our way out of the risk? What are the various reporting formats related to risk-related activities? And how do we track these documents? So it all depends upon the size, complexity, importance, and the development approach you are using that you would develop a risk management plan. This diagram generally shows that a simple project which is close to certainty and the requirements, we have almost the agreement on them. So such a project is a case for a predictive project management. As the uncertainty and risk increases, we cannot do that with a predictive project. Within a predictive project, we may have to change our strategy. We have to either go hybrid or we have to go adaptive. That is for complicated and complex situation. Complex situation is can only be handled by agile method. But then there is a limit to that as well. Limit to the complexity. Even if complexity exceed a specific level, beyond that specific level, the things are so chaotic that are fundamentally risky. We cannot handle that in a project at all. So if your risk levels increase to that fundamentally risky, chaotic zone, then probably you should close down the project abnormally. That is, we can't afford to take that much risk. So we abandon the project for that case. So you have clearly seen that complex situations can only be handled with adaptive planning or agile method. Simpler cases are taken over by the predictive project management. So do understand that a more complicated projects probably cannot be handled with a predictive approach at all. Anyways, this was just to give you an idea how the complexity exists within different environment. Then how to identify the risk. We have got various methods of risk identification when we are gathering the data and analyzing that about the risk management. We actually use various tools or techniques. One is called a risk breakdown structure, in which we define the various categories of risk and then we explore each category to find out the explicit risks which could occur, which could affect us. We could do brainstorming and be a little bit creative and try to explore out of the box ideas, because risk is not kind of a logical thing which will happen according to your knowledge. It could be strange things happening to you, and you may be able to identify risk only when you are thinking out of the box. Then we have got a nominal group technique, which we have already talked about. We have SWOT analysis, we have talked about. Affinity diagram, also we have talked about. But just to show you, affinity diagram is a technique that allows large number of ideas to be classified into groups for review and analysis. So that means affinity diagram is a good tool to develop a risk breakdown section. Then we have got assumptions analysis. In your project, when you start your project, you take a lot many assumptions in the life of the project, right? Now, why do you take assumptions in a project? What is your take on it? Why do you take assumptions in a project?
Because there are uncertainties regardless.
Yes, you're right, in the right direction. You are actually, all the data could not be available, right, about the project. Naturally, you are right in saying that there is uncertainty in the project. So, well, you can think of lot many things, but you can't think of everything. So, for example, I am trying to do something which I have never done before. So, I don't find any data to calculate things. So, what I do is, I say, because there are no factual data available, let us assume that this can be done in this manner. That is an assumption which might prove right or might prove wrong. Because there is a probability of this assumption going wrong, so that is a potential candidate to become a risk. So wherever you have taken assumptions, you must flag them with a red mark, as if you can keep an eye on them, because these assumptions may have a huge tendency to become a risk. Right now they are not, but they may become risk anytime. So I must follow up on my assumptions and keep tabs on them. We could look back at the historical record and the files left out by the previous project. How did they do their risk management? What were the risks they faced? So I can learn a lot from the document review. Delphi technique is a technique in which we have discussed earlier, is a technique in which we have anonymous opinions gathered, as if the opinion of the people is not affected by the opinion of other people, right? Maybe, I ask your opinion and you are sitting with your boss. You don't want to discredit your boss, so you keep quiet and let him coin new ideas. That is, you are suppressing your own ideas. That is something bad. So to encourage all ideas to come in open, we use the Delphi technique, by which we keep all the opinions anonymous. We don't share who gave this idea, but we coin that idea in front of the whole audience, and then they can deliberate. So in that way, no idea remains suppressed. Then we have got a Monte Carlo simulation, which I'll talk later. It is not really associated with the risk identification, but this is a technique for quantitative risk analysis. This is an example of a risk breakdown structure where we have broken down our risk into various categories like technical risks, management risks, commercial risks, external risks, and maybe few more. Under each category, we will create a subcategory. For example, under the technical risk, we say there might be technical risks regarding scope definition, regarding requirement definition. So far, I am not identifying the risk, but I am just creating categories under which I'll start looking after the risks. So say these are 4 main categories, out of which there are 6 subcategories in each one of them. So there are around 24 subcategories. Imagine if you start exploring each one of these 24 classifications, you probably may be able to identify at least 10 risks in each category. So 24 multiplied by 10, it comes out to be 240 risks. So this is a very convenient exercise by which we can identify large number of risks by breaking it down into various risk breakdown structure levels, categories and subcategories. So this chart shows our risk breakdown structure. Then we have assessment of the risks. We have to assess the risk. Each one of the risks which have been identified must be assessed either by a qualitative method or a quantitative method. What is the difference between qualitative and quantitative methods? Any opinion?
The other is the description or opinion, and the other has values, numbers.
Right. So the qualitative risk analysis is subjective in nature, whereas quantitative analysis is objective in nature. Subjective means that it is kind of statements given by people, whereas quantitative is mostly in a figurative form. It is in figure, right? So we have to do the qualitative assessment first before we can get on to the quantitative analysis. For example, your project has got 200 activities. Each activity might be carrying certain risks. So there might be hundreds and thousands of risks, more than the number of activities you have. So if you start wasting time in calculating each and every risk to the quantitative details, that would be more time than to plan the whole project. Only the risk management process will take a lot of time. So we don't get into the quantitative calculations, the detailed calculations. We rather start with a broad categorization of risk, which is called qualitative assessment. And we try to sort out, like, I want to brush out those risks which are bigger than others. When I have done that from apparent qualitative assessment, then all those risks which are not coming up to that standard will be dropped down. Now, what we do is we develop a probability and impact matrix for all these chosen big risks. This is probability and impact matrix is trying to segregate those risks in various categories, as if I can recognize which are the bigger risks, which are the smaller risks, and then I can address a risk larger than a specific size, and we will take them into account. Quantitative assessment can follow, but that is not for the purposes of individual risk. That is to assess the cumulative value of risk of the whole project or a portion of the project where the risk is high. I want to recognize that portion of the project, and we don't want to go into the detailed calculations of every risk. Only some of the risk will qualify to go to the quantitative level. Now, before I can talk about the probability and impact matrix, look at this chart. We have kind of categorized them on a level of 1 to 5, from very low to very high. Very low is 1, low is 2, medium is 3, high is 4, and very high is very high. That is 5. Now, you understand that a risk has two things. One is the probability and other is the impact. Probability is very simple. What are the percentage chances of this risk occurring? If the percentage chances are low enough, and you can devise your own grid, you can devise your own limits, because these limits which are explained here, they might not be suitable for your project, because probably this example is created out of a mega project, right? So here it says that if it is 1 to 10%, we will consider that a very low risk. If it is 11 to 30% probability, then it is a low risk. If it is 31 to 50, it is medium, 51 to 70, high, and anything more than 70% is considered a very high risk from the probability point of view. Now let's talk about the impact. What is the impact on the project? The impact could be from the scope, from the time, from the cost, or from the quality. So we would say, okay, time and cost is easy because they can be figurative, but as far as the scope and quality are concerned, that is going to be qualitative value. So let's not talk about it. Time. For example, if there is a delay of 1 week, we consider that very low. I am not saying that this is going to be true for your case. Maybe you have to amend these limits from your project risk management point of view. But anyways, the example given here is 1 week is considered very low, 1 to 4 weeks delay is considered low, and 1 to 3 months delay is considered medium, 3 to 6 months delay is considered high, and anything more than 6 months delay would be considered very high. Anyways, you can create your scale. Similarly, for cost, for quality, for scope, and then all of these things, scope, time, cost, and quality, you will have a cumulative value associated with it from 1 to 5. So basically, we are interested in probability and the overall impact. So I will have two values in the range of 1 to 5. One for probability and the other for other effort. Now, once we have created that map, we will have to plot it. Just look at it. On the x-axis, we have the impact or the severity from scale of 1 to 5. On the other hand, on the y-axis, we have the probability or the likelihood of certain risks occurring from 1 to 5. So basically, when I create this grid, that means the risk is calculated by multiplying the probability with the impact. So probability here is 1, impact is 1. So 1 multiplied by 1 is 1. So what do we have here? We have 3 is the impact and 2 is the probability. So 3 and 2 is 6. And what is this? This is probability is at the level of 4 and impact is very high. So this is 5. 4 into 5 is 20. So basically, we allocate these boxes and then we color code them. We say anything more than 15 or more would be considered as a risk. All others should be treated as small risk and they should not be entertained at all. I mean, I don't mean to say that we don't recognize them, but if they occur, they will cause the damage at a very low scale. but the risks which are more important, which are in the red or the purple zone, they are considered to be my risk. All others are just put aside. This is our demonstrated copy of a risk register. It could be looking like this, or you can even improve it. So I'm not suggesting a format, but I'm just giving you an example. For example, these are the three risks. You make to develop different columns, like impact description could be provided in front of the specific risk here. Impact level score 1 to 5, that could be here, that could represent time, cost, scope, and quality. And then we have got probability from 1 to 5. And then we multiply the value of impact with the probability. That is, value of impact is 5 and probability is 1. So 5 into 1 is 5. This one is 10. Next is 9. So if somebody asks you which is the biggest risk, I would say this one. Then we have got trigger conditions. What is going to be the indication of this specific risk occurring or surfacing in our domain? Then we have got our response action. What should we do to reduce the impact of that risk? And then you must assign an owner to each and every risk. In an agile project, we may not have such an elaborate risk register, but in agile, we call it a risk list, not a risk register. And it has got a much simpler format. Although you are allowed, if you like, that these things are important, maybe the name of the owner, maybe the status of the risk, maybe the date of identification, date of resolution, active dates, resolution strategy, all of this could be input to you. Then we do quantitative risk analysis. We run simulations. We do Monte Carlo analysis, sensitivity analysis. We draw tornado diagram. There are many ways of doing the quantitative risk analysis. But basically, what we need to know is what is the total risk of the project. So we will accumulate or add up all the values of the risk in quantifiable terms, right? So that is quantitative risk analysis. And this quantitative risk analysis also happens in sensitivity analysis, in simulation, or even in a tornado diagram. Tornado diagram, you can see it looks like a tornado. It is wide on the top and it is small on the bottom. So basically, all the bigger risks have gone up, whether they are positive or negative. Positives will occur on the right-hand side, negatives will occur on the left-hand side, right? But generally, this is the pattern it will look like, and that is very much like the concept of a tornado. So for quantitative risk analysis, we have got various tools. We have got decision trees and a tree analysis, influence diagram, if decision trees can't serve our purpose, and we have expected monetary value. Risks, time, cost, and life cycle. Predictive projects are most often affected by the impact of cost-related risk, whereas adaptive projects are affected by the impact of time-related risks. So, do you think each of these typical risks is more typical of predictive or adaptive project? Can you explain why? What is more predictive? What is more adaptive? Yes, please.
So, for example, the first one, the delivery date slips, they are for adaptive.
Uh,
Because time related,
well,
right?
you see, date slip, how is it adaptive? Because there is no concept of date slip in Agile. In Agile, we have got a fixed time frame of 1 or 2 weeks, and whatever we can do in that 2 weeks, that is that is our decision, right? So we are not slipping the time. Either we do it or we don't do it. We don't slip on time. So delivery date slippage is a predictive problem. We are more worried about that we will get delayed and things like that. In Agile, there is no concept of delay, right? Stretched resources. Where are the resources much stretched, predictive or agile?
Predictive.
Predictive, yeah.
Predictive because in agile, we have got a limited number of resources available. So we are more comfortable, easy to work with.
Okay.
Lack of clarity is a big problem. And that happens in predictive or agile.
Agile.
It is agile because this lack of clarity breeds further, unclear situation. Scope creep, what is it? Scope creep
Predictive.
are those changes to the scope which have been brought about without proper change control mechanism, right? So if they are unauthorized changes, and we need to fix them as soon as possible. Risk responses. Let us move on to the risk responses. Before that, let us talk about what is a primary risk and a secondary risk. The risk which is identified is a primary risk, but there might be another risk hiding behind the primary risk. Until and unless primary risk gets out of the way, we can't even see that. So, secondary risk is a risk hidden behind a primary risk, right? So, these are called secondary risk. Then we have got residual risk. I have a risk which I have treated, right? And I have kind of uh, tried to, the secondary risk can arise as a direct result of the risk response implementation. When the risk response is applied or the risk is being analyzed, we find that there is a risk hiding behind that risk, and that we must entertain that risk in our fold as if we can entertain them. Residual risk is the leftover risk. We have treated our risk already, but some of it is still left. That is called residual risk. Then we must have two concepts about one is about contingency or fallback plan, and other is about contingency reserves or allowances. But what does it talk about? You see, contingency plan is for issues. It is not for risks. When a risk occurs, we get into the issue management, and contingency plan is the alternate plan which the planning people have already created in case any such situation occurs that the internet is down and things like that. So, whatever is left over is the residual risk, and whatever we do in the fallback plan is when the risk has become an issue. As far as reserves are concerned, we have already discussed that contingency reserves could be amended or added throughout the life cycle of the project. These are our various risk strategies. 5 strategies for dealing with negative risk and 5 strategies for dealing with opportunity. Incidentally, the first top level, escalate, is applicable to threats as well as opportunities. Well, that is, if we find out that this risk cannot be handled by us, we can't devise a response to that. because this is a matter bigger than our project. So maybe we have an escalation path defined, and the management who is giving us our requirement, they explain them in a better fashion. Second thing is we try to avoid the risk. We get out of the way if it is a bad risk. We transfer the risk. We may ensure ourselves or our office or our premises, that is risk transference. Then we have got mitigation, accounting. These are the various methods. Sorry, not accounting, acceptance. Acceptance is that without, you know, any intimation, we we can engage with that part. Opportunities, naturally, after the escalation, you can't escalate it, then you exploit it because it's a positive risk. You should share it with your team members and enhance the functionality. Which of the following is a good example of mitigating the probability of the risk of becoming overwhelmed with a fire in a newly constructed building? Yes, please.
Letter B.
Bravo.
Yeah, bravo. Or,
You see, it says mitigating the probability, but this second option is talking about fireproofing. That means it is not talking about the probability, it is talking about the damage it will cause.
So A.
A is the very right answer for that. You install smoke detector, which will give you early warning, and you could, you know, deal things better. What is the difference between avoiding a threat and mitigating it? Yes, please.
letter C.
Let us see. Right, very right. So we are done with this portion, and now the next topic is going to be quality. But because we have almost run out of time, so I would like to stop here. If you have any questions, you can ask.
No questions on my end. Sorry.
No.
Okay, wonderful. Then let's call it a day and see you tomorrow from this slide onwards.
Mhm.
Thank you
Thank
very much
you.
and take care.
Thank you.
Bye.
Bye.